Okay, in this problem, they give you a velocity function that's modeled by a piecewise function. Part A asks you to integrate the velocity function. So I know that because the entire graph is above the x-axis, the integral will just represent the area underneath the curve. So I'm just going to use the formula for the area of a trapezoid. So area of a trapezoid is 1/2 times the height. The height of the trapezoid is 20, and then the sum of the two bases, which is our 24 and 12. So this ends up being 360 meters. So this is this. Oops. Okay, that's the first part. Okay, and then it asks you to explain the meaning of this. So because the entire graph is above the x-axis, this is your total distance traveled. So that's the meaning of the integral. And remember, you want to explain your bounds. Actually, let's use units first. Total distance traveled in meters from t equals 0 to t equals 24 seconds. So make sure you use units in all explanations. Make sure you explain what these bounds represent as well. Part B. First piece, v prime of 4. So the graph is the graph of v, so v prime will be the derivative of this graph at 4, but if I look at the graph, I notice there is a corner, so the derivative does not exist. Okay, and let's also do v prime of 20. So at 20, if you look here, that's the point on that graph. The v prime of 20 is just the slope of this line here. And you know this point is 24, 0. You have this point, so you can just find the slope of that formula, of that line, using slope formula. So I get -5/2 meter per second squared. Okay, for part B, it also asks you to explain why it does not exist. The reason why v prime of 4 does not exist is when you look at it graphically, obviously it's because it's a corner, but the reason why it creates the corner is because the derivative from the right-hand side, as you approach the graph from the right, notice the derivative, the slope is always 0, and the slope approaching that point from the left-hand side is a positive slope. So those slopes are not the same, so that's why graphically it creates that corner. So that's what you want to do in your explanation. It's because the derivative from the left and the right are not the same. Okay, you don't want to say it's because I see a corner in the graph. You want to explain why is there a corner. Okay, part C. Okay, part C is asking you to write a piecewise function for the acceleration graph. So all I'm going to do is go ahead, and I know that acceleration is the derivative of this graph, so I see 3 separate lines. So the acceleration is just the slope of each of these lines. So I'm just going to use slope formula, and if you look at this piece, the slope of that piece is 5. The slope of the middle segment is 0, and the slope of the last piece, which we already figured out from part B, is -5/2. Now you need to put all the intervals. So this is only from 0 to 4, this is only from 4 to 16, and this is from 16 to 20. And notice I don't have the equal signs any of them because at these intervals you have that corner, so your derivative or acceleration graph will not be defined. So you want to make sure you don't have that. Okay, lastly, part D, find the average rate of change of v. Average rate of change is just another word for slope. They want the average rate of change of v, so you should be thinking v of 20 minus v of 8 over 20 minus 8. The graph you're given is the graph of v, so you can get these values from the calculator. I get -5/6 meters per second squared. Make sure you put units. And explain, does the mean value theorem guarantee a value of c such that v prime is equal to this average rate of change? In order for the mean value theorem to hold, the function has to be continuous and differentiable. We're talking about v now. This is the graph of v. It is continuous, but it is not differential. So v is not differentiable, so mean value theorem does not hold, does not apply, or something along those lines.